let me give you a brief roadmap. First, I would like to speak about the project, the background of the project, then the goal of the project, then the technical solutions we applied with respect to special attention to the applied network solutions, the grid in operation, relationship with our institutes and our users, and finally to conclude my presentation. So, so the background of the project dates back to the spring of 2002, when the Hungarian Ministry of Education initiated a procurement project which aimed to provide hardware infrastructure to Hungarian universities, high schools and public libraries. This project was definitely successful, and within the framework of it, 99 computer cabinets have been deployed throughout the country. Each computer lab consisted of 20 PCs and a single server. It was quite reasonable to use this enormous resource for grid purposes. So we put in the contract with small letters that the institutes should provide the hardware for grid purposes whenever they don't use it for any other thing. In the summer of 2002, a so-called cluster grid technical board was set up, coordinated by Hungarian, and the purpose of this board was to create a feasible technical solution with which we can integrate this enormous number of machines into a large supercomputational unit. The operation of this board was also successful, and a pilot project was finished in December of last year, involving 3 institutes. So the goal of the project is the following: to build a country-wide homogeneous grid system, which is a production-like grid system, which provides service to real users and which is capable to solve real problems of the real users. The institutes can use the machines in 2 ways. The first one is the original institutional usage, which we know night shift, and for grid purposes, which we call, day shift, and for grid purposes during the nights and the weekends, which we call night shifts. Just a couple of words about the technical solutions we used. There are 2 keywords which we call temporal and spatial separation. The spatial separation means to use a separate operating system, separate disk partition, and separate network segment when the computers are in grid mode. Temporal separations means to use the computers for grid purposes during the nights and during the weekends. The applied solution is not a strict grid system in terms of the relation among the clusters, but a 3-layered hierarchical system having a central entry point on the top, local masters in the bottom, and the worker nodes in the middle and worker nodes in the bottom. And it was also a task to create a system which is as easy to manage as possible. In the current implementation, the system is centralized, but it can be decentralized on demands of the institutes. There are 3 building blocks of the solution which distinguishes it from any other Hungarian grid projects. The first one is not to consider the network as a cloud, which we on which we don't know anything. Instead, we developed or we proposed to create a private network structure using multi-protocol label switching technology. And whenever the workers are in grid mode, they are part of this private network. Why MPLS? It would be a good question. It gave us instant and quick solution. This is why we have chosen this technology, private network technology. The second key idea is to use network root file system on the workers. This is for manageability purposes. Because the image of the root file system of the workers can be maintained on the local masters. And the third key idea was to make the switching between the grid mode and the ordinary institutional mode as automatic as possible, using so-called wake-on LAN technology. In the figure, you can see the scheme of the network structure. You can see the entry point on the top, the MPLS private network, the local masters, these are the local masters, and the clusters themselves, and some addressing issues as well. The main purpose of the workers, they provide the CPU and the memory resources, and they are also NFS root clients. The role of local masters are really key. They have really important functionality, since they provide the NFS service to the workers, and they also provide dynamic IP address assignment to the workers. And also they are TFTP servers, just to let to boot the systems, to boot the workers. And they also, if you see the previous figure, local masters function as gateways between the private network and each cluster. The function of the central entry point is basically to provide authentication service, which is carried out by LDAP, Open LDAP server, and to provide DNS service to the private network, and also to provide a user interface to as a front-end machine. As a grid operating system, Red Hat Linux version 7.3 was chosen, but due to the overwhelming number of people in the technical board who are Debian gurus, developed the configuration to Debian as well. Just a couple of words about some restrictions. The first and most crucial restriction is that the central machine and the local masters must operate 24 hours a day. The second important thing is that the boot process of the workers is a really complex task, but it's beautiful. Unfortunately, I don't have enough time to detail it, but if somebody is interested in this question, I can tell him in private the whole boot procedure of the worker. The boot process can actually be done from any media, for example, from CD-ROM, from floppy disk, but the most preferred is to boot the workers from the network using PXE boot. And as I mentioned before, switching between different modes must be as automated as possible. This is carried out by local administrators. Whenever a lab is closed in the evening, all the machines are switched off. And after an hour, a local vacant LAN signal is released on the network, and all the machines, all the workers come up in grid mode. The grid software. Currently, Condor is used. We investigated SunGrid engine before, but it needs some workaround to do, which we haven't done yet. But Condor gave us also a really real instant solution. Currently, sequential jobs and parallel PVM jobs are supported, and unfortunately, neither MPI nor Globus is used in the system. The current implementation. There are 8 Hungarian institutes involved in this project so far, but the number of institutes have been increasing. 5 of them is located outside of the capital, which is I think it's a major achievement. The sum of 400 nodes are enabled for grid operation, but only 200 nodes are actually functioning. The reason for the reason why there is a gap between the 400 and the 200 is quite simple. Some of our institutes switch off the electricity after 8 o'clock and invalidating all the workers in grid for grid operation. These statistics are valid, were valid a month ago when I was preparing the slides, so the numbers are, have been slightly increased. Just to give you a map all about this, you can see the abbreviation of the institutes in the top of the bubble and the number of contributing nodes in the bottom. Note that both the Eötvös University of Sciences and the Technical University of Budapest gives major contribution to the cluster, but also other institutes give smaller clusters, but they are as important as the large ones. This figure is made for the skeptic. It shows the statistics, Condor pool statistics, the total, I mean the green area plus the blue area together consist, the nodes, the number of total nodes booted in grid operation, and the number, the green area shows the proportion of the occupied machines. So you can see around 200 machines are operating. This statistics was made a week before I made the slides. So it's basically a weekly statistics showing each night in grid operation. Just a few words about our relationship with the Hungarian partners. Each institute must provide 3 responsible people. First, an IT manager, a Unix admin who actually runs the lab, and the network admin. In successful cases, these 3 roles are integrated in a single person, which simplifies our job. In spite of the tough conditions in some institutes, all participating partners should possess several conditions. First, they should guarantee that the machines are capable for continuous operation. They should provide appropriate networking, especially on the second layer of the networking reference model, which means they should be capable to create virtual LANs. And they should provide 8 GB disk partition on each worker for swap and also for scratch purposes. And they provide a dedicated server. our users. There are 4 users so far, which sounds quite funny, but they are real users with real problems from the fields of physics and chemistry. And due to one of our users, the first international journal paper has been created based on the computations carried out on our cluster grid in the field of chemistry. And also anybody who is interested in using this resource and is an Hungarian academic, belongs to the Hungarian academic community or one of its partners, can use this resource for free of charge. We have an official website. Unfortunately, it's written in Hungarian, and I'm going to release the English version in a week. We have also got a mailing list, and any questions are welcomed on this mailing list. Just as a summary, I have been talking about the project background, the goal of the project, technical construction, the grid which actually functions, relationship with our national partners and also our users. And as for the future plans, we have many new ideas in terms of improving the system in quality and in both in quality and quantity. And however, we have limited resources in terms of financial and human resources. So we need to set up feasible solution in terms of finance. So thank you for the attention.
So, any questions? Yes. And it's a microphone. If you
Have you had the opportunity to run any benchmarks on it?
Not yet. Unfortunately, not yet, because we have tried to install a benchmarking test, but so far we haven't succeeded in doing this. So it would require MPI support, and MPI is not yet supported on this platform.
Okay.
My question is, in your architecture, is it possible for 2 remote workers to run an application in parallel? I mean to distribute a big application for 2 remote.
Yes, because all the clusters are connected together by using Condor's flocking mechanisms. This enables what you are asking.
It doesn't affect the network infrastructure bandwidth, because they have to connect with exchange data with huge amount, I think, if you want to run a big application. Have you tested any result of running the big application in parallel with 2 remote nodes?
How big application do you think?
Like the physics or physics application that?
Yes, one of our users once occupied 100 machines. This was the largest job we have seen on the cluster.
Thank you.
What are the tasks of the clusters during the daytime? Are these classes of students or what?
Yes, they are basically computer labs. The institutes provide educational service or browsing service or any type of function.
Any other questions? No? Well, thank the speaker again for a very clear talk. Thank you very much.
There was one more question.
Was there? Oh, sorry. Oh, the hand was hidden. I apologize. Behind the pillar.
Can you set local managers to work alone? I mean, one institution have own project for grid computing, and this institute can run own process on a local cluster without getting up to entry point?
So far, centralization is not a technical issue. However, the system is centralized. It's an administrative issue. If an institute claims that, hey, I'm going to manage my own entry point, in this case, they can be split up by the tree-structure hierarchy, and they can set up their own entry point. And in this case, they can use their own cluster for their own jobs.
Technically, you can just cut off lines and have one cluster isolating and working alone. I mean, if you have one institution and you have private network to entry point, centralized private network.
Yes.
Suppose you don't have a connection to central entry point, and this institution can't operate alone with own cluster.
But this is not supported. This whole project is on integration of resources, not the separation of my own resources from the others. So it's conceptually not feasible.
I'm only interested, what is the equipment, the computers, their speed, and so on?
Yes.
The amount of RAM and so on.
They are high-quality computers, IBM Intel Station. The PCs are IBM Intel Stations and HP Vectras. And the servers are also higher and IBM and HP machines.
Okay, thank you.
Okay. So thank you again, and now we can thank the speaker again. So